Let me just wait for the recording to start. Okay, so Unit 2, Component-Based Software Engineering. So I'm just going to take you through the introduction. So developing a software from scratch has become inefficient in terms of cost and productivity, and we discussed that last Tuesday as to why. The introduction of developing independent, flexible, reliable, and reusable components using the concept of component-based software engineering, or CBSE. Don't get confused. When I say CBSE, I'm not talking about some new station, okay? I'm talking about components-based software engineering. So in this study unit, components models are discussed in detail, as well as support which may be provided by using middleware on those models. For those who weren't here last Tuesday, just to put it in simple terms, you can look at software reuse in general as a way of cutting corners, okay? But you're cutting corners in a good way because you're not compromising standards and so forth. In actual fact, software reuse works in your favor because you get to use components that already exist, and they've already been tried and tested, okay? And we can do software reuse at different levels. We can do it at the software level at the system level where we're reusing the whole ecosystem, which means within that system, there's other applications as well, subsystems. We can reuse the whole ecosystem. And then we can do reuse at the application level where we're just focusing on a specific application. We can do it at the component level, which is the focus for today's class. And then we can also do it at the object level, just to provide those who are not here with a bit of context as to where we are. So we will cover the following outcomes. So demonstrate a detailed knowledge of the term software components, which may be included in a program as an executable element. Demonstrate a detailed, thorough understanding of the key elements of software components models and evaluate the support provided by middleware for those models. Demonstrate an understanding of key activities in the component-based software engineering process for reuse as well as the CBSE with reuse. Demonstrate an understanding of the three various forms of component composition and problems which may be encountered and how they are going to be resolved during the component composition of new components or a system. Okay, so moving on to the next slide. So what is a component, or how do we define a component? We say it is a independently deployable implementation of some functionality, and that aspect of independence is very important. For a software component, what it provides and what it requires should be clearly stated so that it can be used without any ambiguity. Okay, so this component needs to be very well documented as to what it needs to function and what it also provides to other components. They communicate through what we call remote procedure calls. And one thing about components, they don't even have to be on the same machine. They don't even have to be hosted on the same computer. They can still be able to communicate with each other through this protocol called RPC, which is remote procedure calls. Okay. Now, you can see here, there's an image of how a typical component is represented. Obviously, this is in a logical manner. And you can see there's two interfaces here. A component will have a requires interface, which defines the services that are needed and should be provided by other components. Okay, so the input, look at it in terms of input and output. So it requires input before it can perform its particular task, that particular component, and that forms part of the requires interface. And then the provides interface on the right-hand side defines the services that are provided by the components to other components. So after it's finished performing its process, then it's going to provide a particular output for the next component. So we refer to that as the provide interface. So typically this is how we define this, the particular aspect we'll touch on when we're talking about a component, knowing that it's independent, knowing it has those two interfaces, and knowing how it communicates. So this concept of coupling and how it ties into components reuse. So coupling is the indication of the relationships between modules. Coupling shows the relative dependence or independence amongst those modules. While designing, you should strive for low coupling. Dependency between modules should be less. Okay, now, if you look at these two programs here, the orange one and the green one. So from what we see on the orange one, there is a high level of dependency because the class or the module that's doing the functionality, the inputs, the adding, let's assume, I think this would be for a calculator. Okay, so the class that's doing the adding, the inputs, and the displaying, it's all bundled into one. Okay, compared to the one on the right-hand side, which is the green one, and you can see that they separated. Okay, so these are, in this particular program, they are loosely coupled. We say low coupling or loosely coupled. So the parts of the program that's actually doing the display and the parts that actually doing the functionality, subtract, multiply, divide, and add, are separate. And what that does is it ensures independence and it supports the concept of reuse. Where there's high coupling, very difficult to do reuse without having a rollover effect. Okay, so on the loosely coupled one, we can take, perhaps we can change the window and redesign it. Maybe give the code to someone else who wants to code their own calculator. Just give them the calculator class. They'll have all the functionality, and all they have to do is sort of code how they want it to look in terms of display, which is the window class. So you can see the importance that green is good, and this one, whether you look at it as red or orange, is bad. Okay. So then what is this CBSE? It's an approach to software development that relies on the reuse of entities called software components, improves on object-oriented reuse since single object classes are too specific, okay, too detailed. So they're too specific and too detailed. Here they're talking about the lowest level of reuse. And they're saying that this component-based reuse is actually an improvement because we went one step higher. Once you reuse one step higher, it means you're saving the person more work, okay? You're saving them from doing more work because at the object level, what had happened was we reuse code from buttons, code from text boxes, and so forth. So you just simply copy and paste the code from a button and you paste it onto the new program, okay? But that is too specific. How many buttons are you going to have in a software? How many are you going to copy and paste? Maybe on that particular components that you're actually trying to reuse, you have more than 50, for example. So this component-based one is one level higher, and it's more convenient. Okay, it's an improvement. So the goals of CBSE is improved maintenance and upgrades. Once you develop components with a level of independence, then it becomes easier for you to do maintenance or separate any problematic components or nodes. So standards are important, okay? Because standards ensure that component vendors actually build these softwares the correct way. And a typical component will have these particular well-defined standards, okay? They say that standards define how vendors build components to ensure functionality, reliability, performance, usability, and other quality factors. So to ensure all the non-functional requirements are met for a particular component, they need to sort of be compliant in terms of these. So you can look at the component model. A component must have interfaces. Okay, it must have interfaces, and those are the requires and provides interface. Either one of those, but it has to have an interface somewhere. And a component must have a naming convention. Remember that these components can communicate remotely. So there has to be some sort of naming convention defined so the other components can be able to access it using what we called remote procedure calls. And also a component must be well documented, okay? It must be well documented. So some of the component identification issues that you may experience, okay? So the first one is trust. You need to be able to trust the supplier of a component. At best, an untrusted component may not operate as advertised. At worst, it can breach your security. So don't just be taking anything on the internet just to be cutting corners, because what could happen is you can actually download a fake component or a Trojan, or you can, yeah, it compromises your security, because here you are downloading a component thinking it's serving its purpose. Just imagine on a software that's supposed to be processing payments for your customers, and you use a payment gateway that's not trusted and doesn't have good security. So your whole e-commerce process is now compromised. Okay, so trust is everything. Always go with authorized providers. And in terms of requirements, different groups of components will satisfy different requirements. Okay, so you need to get the one that speaks to what you're trying to do. In terms of validation, the component specification may not be detailed enough to allow comprehensive tests to be developed. Components may have unwanted functionality. How can you test this will not interfere with your application? Okay, so some of the challenges that you may have is that there's not enough documentation or specification, and so you're not able to run a thorough testing process for this particular component. And that's a big challenge for you. And sometimes these components come bundled with specifications that you don't even require. And those particular specifications end up being the ones that are making it crash, yet you're not even going to use them in your particular software. So the CBSE process can take two forms. And I think we briefly discussed this last Tuesday, and he said development for reuse, and then there's also development with reuse. When it comes to development for reuse, it's the development of two or more components or services meant for reuse. So here you're building components that can be used by other people. And then when it comes to development with reuse, the development of new applications using existing components. So one would typically come before the other, okay? And we're gonna see that, I think, in the next slide. So if you look at this particular diagram, it sort of shows you the flow process of CBSE. And what would typically happen is that the vendor or the supplier would first design a component for people to use in the industry. And what happens is that once they design and code it, then they have to put it in a centralized component management system or repository, okay, where it gets certified, usually both by a local and an external component certifying organization. And you can imagine this is for standards purposes. We mentioned the standards in the previous slide. So it's for standards purposes. And after the person develops it, then it goes to that particular repository. Then people that want to incorporate that component in their softwares would then, we would refer to them as doing CBSE with reuse, okay? Because they're reusing a component that was built by someone else. So they will get it from some sort of centralized repository, okay? So you can see from this diagram how CBSE for reuse flows into CBSE with reuse. And this is the typical process for with reuse, where you outline the system's requirements, your system's requirements for the system that you are building, and then you identify your possible initial components that you would reuse, and you modify, then you go back to your requirements and you modify based on your initial findings, modify your requirements accordingly, okay? And then you also choose an architectural pattern or architectural design. You may need to go back to your components and see which ones are compatible with the particular architecture that you are using, okay? Because they may not be compatible. And then compose the components to create a new system. So this is a typical flow for CBSE with reuse. And then we have different types of component composition. And here we're talking about the different methods that you can use to integrate these components together. We have three main ones. So we have sequential composition, we have the hierarchical composition, and we have the additive composition. When it comes to the sequential composition, a component is created from two existing components. So the existing components must be in sequential order. This type of composition is the provide interface. So with this particular composition, we have component A and B. And before B can do its work, it has to wait for A to finish. Okay? So that's why we say it's sequential. Okay? Sort of like a home page and a login form. Okay, there's no way the login form cannot wait for the login page to first establish a session ID. Okay, so that would happen in a sequential manner. The person has to log in first before they get taken to the home page. And we also have the hierarchical composition. One component calls directly to another. The calling component is the requires interface, and the called component is the provides interface. So with this particular composition, B can call directly A. Okay, it's not really in a sequential manner, but B can really actually call A directly. Okay, and then you have an example here of a order component where it's requesting or calling the product component, asking for the product or the item code, and it can also call for the customer component, asking for the customer's details, and also the account details from the account component. Okay, so this one is direct calling between the component. And then you also have this additive composition. Two or more components together to create a new component combines functionality of A and B. A and B are not dependent and do not call each other. We can look at an example of this would be a chatting application. Okay, so we have a component that controls, let's take let's take Teams, for example. We have a component that controls video, and we have a component that controls audio. These two components work together, okay? They combine the functionality to create a system, but they don't call each other at all. In actual fact, the video can cut, but the audio can still continue. So there's a high level of independence here, but we need these two components together, because imagine if we had this call and there was no audio, okay? And there was no video, or either video or audio, it will be a disaster. You won't be able to see what I'm presenting here in front of you. So you can imagine with this additive composition, then there's independence. They don't call each other directly, but they need each other to complete the picture, the bigger picture. And then some problems that we face with interface incompatibility. When components are developed independently for reuse, their interfaces are often incompatible. 3 types of incompatibility can occur. We can experience perimeter incompatibility, which is when the data that is being generated as an output by one component is a different data type than which is expected by the second component. Okay, so here it goes back to the perimeter. Maybe the other one is expecting a string, and the one that's providing the particular perimeter is generating an integer, for example. Now we have integer and a string, so we have perimeter incompatibility. Then we have operation incompatibility, where the names of operations in the composed interfaces are different. Remember, I said part of the standards is that a component must have a well-defined naming convention. If you don't have a well-defined naming convention, then the components won't be able to communicate or access each other using remote procedure calls. And that's where we have operation. It's an operational issue or incompatibility. And then also operation incompleteness, where the provide interface of one component is a subset of the requirements interface of another. So maybe here only part of the data is sent through. For example, if we want someone's date of birth, we're expecting a date of birth, but then it only sends the year and instead of the month and the day. So that is an example of operation incompleteness, okay? The requires interface for the second component is incomplete, so it cannot do its work. So these are the common interface incompatibility issues that we can experience. And how do we work around this? And we'll talk about it in the slide that follows. So we make use of what we call an adapter component. And it addresses the problem of component incompatibility by reconciling the interfaces of the components that are composed. So we have 2 components here. We have a component, we call it address finder, okay? And this particular component looks at a phone's database, uses a cell phone number, finds the address of someone, okay? And then we have, let's refer to it as component B, which its name is mapper. So the role of component B is to now take this address and display it in a map, okay? So we have, let's assume that we have a interface incompatibility here, where we have an operational, okay, not really an operational incompleteness, but we have an interface incompatibility where this mapper component is expecting a postal code and only a postal code. But this address finder is finding the complete address with the street name, the unit number, the complex, and so forth. We have a problem there. And we can use what we call an adapter component, which sort of operates like a middleware to solve this particular problem. And I'm just going to show you in the slide that follows. Okay, so composition through an adapter. The component postcode stripper is the adapter that facilitates the sequential composition of address finder and address mapper components. Okay, so we declare a address object and we say address finder.location.phone number. So we strip an address from the person's phone number from a phone book database, okay? But we get the full full address, residential address. And we declare another one called postcode. And this is with the help of this postcode stripper, which would be a component that is called an addressor class, okay? Because the duty of this is to sort of strip from that address, this address variable that we declared, is to strip the postal code from it, okay? And it ignores the rest of the part of the address. And then we have mapper.display map. So this mapper component is able to do its work. So based on the previous slide, you can see by adding an adapter class, its main purpose was to just isolate that postal code so that this mapper component gets the correct input. Okay, so it's also able to do its work. And so in conclusion, CBSE is a process of reusing components, and they are executable components. Components must communicate through well-defined interfaces, also referred to as glue code. Two services which are provided by components are namely requires and provides interface. So that is the second study unit, which covers component-based software engineering. I'll give you guys an opportunity to ask questions pertaining to this particular study unit, if you have any. You may unmute yourself if you have a question.